Hello guys! For this video, I will be discussing the very first indirect proof, that is proof by contraposition, still under the chapter of proof techniques of discrete mathematics. Why indirect proof? There were some cases when we do direct proof that we actually reach a dead end. We cannot proceed anymore because we cannot apply the rules of math, the different definitions, postulates, axioms, and theorem. And the only way that we can prove that particular case is by indirect proof. And one of the indirect proof, as I have mentioned, is contraposition. Contraposition is sometimes referred to as contrapositive. So contraposition, contrapositive, they are the same thing. Now, what is contrapositive or contraposition? So it looks like this in symbols. This is the original direct proof wherein P, which is our premise, leads to a conclusion, which is Q. When we do a contrapositive or contraposition, we start with not P, okay? We are not going to start with the premise. We are going to negate the conclusion. So we have not Q, and this is going to be our premise in the contraposition way of proving theorems or statements. And then we will arrive at a negation of the original premise, and this is going to be our conclusion. So you say, it looks 100% different, right? So this is the original P going to Q, while this one is not Q going to not P. But there is a way for us to show that they are 100% the same, and that is by truth table. So from our discussion of logic, we have shown that this is the truth values for P implies Q. Okay, so this one. Now, if we are going to negate P and Q, negation means we just reverse the values. So the true becomes false and false becomes true. So that's why we have this part of the table. And we are going to follow the same rule of conditional statement, but this one we will reverse it. The direction of the arrow is from right going to left, because not Q, here is not Q, implies not P. And this is the truth values of not Q implies not P. And you can see here, right? They are 100% the same. That's why P implies Q is the same or equivalent to not Q implies not P. Now let's have some example of doing a contrapositive or contraposition in proving a statement. Okay, so this is the original one. Suppose x is element of integers. If x or 7x plus 9 is even, then x is odd. So from this group of statements, we can clearly see that yung 7x plus 9 is even. That's our premise. And then if we are going to negate this, the opposite of even is odd. So not P is 7x plus 9 is odd. And then our conclusion, original conclusion, x is odd. This one. And if we are going to negate it, that would be x is even. So we are going to start with this one. Instead of starting with P, using contrapositive or contraposition, we will start with x is even. Okay? So there. And that's our premise. So from definition of even, we have shown that x is equal to 2k. We have established this already. And since we want to arrive from x, we want to arrive at 7x plus 9, we multiply, or we substitute, from the 7x plus 9, we will substitute the value of 2k to x. Okay, so we have 7 times 2k, which was originally x here, plus 9. The reason for that is substitution, right? And then we multiply it. That's why we have 14k plus 9 by simple multiplication. And then we will just break 9 to 8 plus 1, and that's definition of addition actually. So 9 is equal to 8 plus 1. So this is still the same. We didn't touch 14k, but we have broken 9 into 8 plus 1. So it's still the same. And then we just put a parenthesis to group 14k plus 8, and that's by associative property. So it doesn't, putting a parenthesis here doesn't affect the value of the entire expression. And then what we do here is we just factor out 2 because both are even. So we were left with 7k plus 4. And then there's still plus 1 in the end, showing that this entire expression, okay, is odd. Because by definition of odd integers, there must be a 2k plus 1. Okay, there's a plus 1 there. So we have clearly shown that 7x plus 9 is odd, which is the negation of the original premise that 7x plus 9 is even. So therefore, we can conclude that if 7x plus 9 is even, then x is odd, which is the same as our original statement by contraposition proof. So that ends our video, and thank you very much for watching, and God bless.